Colleagues, welcome back to the office and to our podcast presentation for today. This is Database Basics for Financial Professionals Part 2. Now, in this series, we have decided that we're going to learn about databases and all the wonderful, fantastic things that come along with it. Databases power every aspect of our computing life, whether it be from our favorite posts on our favorite social media to the photos on our camera to orders on Amazon and more. Everything is stored within a database. However, unfortunately, too many financial professionals don't know how to effectively use this incredible tool. We're pretty good with Excel spreadsheets. Maybe we're starting to dabble a little bit more in dashboarding using tools like Power BI. But when it comes time to actually work with the data itself, most of us fall short. The goal and intention of this series is to help increase this knowledge, to give you the tools and techniques necessary to be able to manipulate data in an effective and meaningful way. If you can understand and master databases, then you can really kind of build any type of report you want. You can integrate any type of application into anything else. You can pull data from the web and so much more. Now, in the first episode of our class, we did our general introduction, talking about the major characteristics of databases, how they work, giving you a good foundational understanding of where they fit into business and where and how you can use them on a day-to-day basis. In our second episode for today, we're going to get started with actually working with the database and working with our first queries of pulling and extracting data out of a database. So today we are going to be diving into a select statement, S-E-L-E-C-T, select. And with a select, we can scope exactly what information we would like out of the database at a very, very granular level to get exactly the information we need for whatever project we're working on. We can then pull that information into Excel. We could make a dashboard with it. We could do whatever we would want. Now, this little tiny, insignificant skill that you're going to learn today is probably going to be one of the most important things that you will ever need to know with databases, because it's the thing you're going to use 99 times out of 100. Knowing how to write and craft a select statement to pull data out of a database is something that I do all day, every day, and it's something that when you know how to do it and you understand it's a methodology and it's a way of thinking, you're going to find that it's easier than you ever thought was imaginable. It can be a little, let's just say intimidating. It might be the best word at first, but it's not that hard. I mean, there's 5 or 6 things you're going to need to know here. And once you know them, you'll be able to work effectively. So we are going to look at the major components of the select statement and how they work together, understanding what the verbs do and what they are intended to provide in the context of your select statement. We're also going to look at something called database cardinality, which is something I teased at the beginning of the first episode last time, talking about essentially how these different tables and databases join together. We're going to take a look at that in the context of that select statement so that we can understand how to pull together our querying in a meaningful way and in the correct way. Because it's really important. Database language, specifically SQL, structured query language, is a literal language. You need to know how to write the statement, to write the statement of what you're looking for in order to get the data that you'd like back in the way that you want to get it back. Now, we're going to do a couple of different types of SQL selects. We're going to do single table. We're going to do multiple table. We're going to look at some where clauses and more. Now, just as a teaser for our next episode, in episode 3, we're going to continue this discussion. We'll look even further into the various tools that make databases easy and effective. We're going to look at some more complicated select examples. Ultimately, what we're trying to do here is give you the information so that you can write your own queries, being able to pull data out. We're not going to try to make you a full database administrator, but as a CPA, as a financial professional, give you the knowledge necessary to be able to do all the types of reporting that you would need to know. Now, before we dive in, just as a reminder, our sponsor for today is, guess what? CPE Today. And if you enjoy this content, how about you get some credits for watching or listening? It's very simple, effective, and easy. All you have to do after watching or listening is go to cpetoday.com and take a short 5-question quiz, and you can get your credits for watching or listening. Today's course code is DBB2. Again, that is DBB2. Using that code, you'll find our course and you can purchase it. And with your purchase, you'll get a CPE certificate, the ability to ask questions, samples, materials, our presentation, and more. Now, if you're a new listener, and welcome, thank you so much for finding us, and thank you so much for your time and attention and being here. How about you get a free credit on us? You can use coupon code ONEFREEPODCAST at checkout to get a credit for any class of your choosing, whether it be this class or anything else. Use ONEFREEPODCAST at checkout for a CPE credit of your choice and a class of your choice. Alrighty, so let's go ahead and dive into our presentation. And we're going to be about half in PowerPoint today and about half actually hands-on. I'm going to be jumping back and forth between the presentation and the sample database, narrating all along the way and explaining and then ultimately showing how to do different things inside of our tool. Now, I struggled for a minute trying to figure out the best way of teaching this class, because databases, there's lots of options, as we talked about in the first episode. We have everything from on a super high-end level like Oracle to a low-end level like Microsoft Access, MySQL, MS SQL, Postgres, Sybase, you name it. You know, there are lots of different tools that you can consider using. But for today, and at least today's class, we're going to be using probably a tool most of you have some familiarity with, or at least have seen. You probably have installed on your computer. And it is Microsoft Access. Now, to be fair, this isn't the best database tool. And I personally never use it other than to teach people how to work with databases. It's not something I would ever recommend that you use for production use, meaning something you're going to actually use for your business in a meaningful way. You know, if you're just looking to use databases, it's fine. But it's a good way to get started. It's a good tool to consider cutting your teeth on some of the basics. And it's a good tool because it also has some sample databases inside of it, which are pretty useful. So if you'd like to follow along, I would encourage you to open up Microsoft Access. If you're a 365 subscriber, it'll be there automatically. Just go to your start bar and type in Access and it'll pop up. And we are going to use the Northwinds database. So let's just go quickly take a look at how we would get started here, and I'll show you how to get this open, and then we'll continue our discussion. So from your desktop, go ahead and go to your start menu, and you could just type in Access, might pop up right away for you. As you can see here for me, it will. And this will pop up the Access database. We're going to be using the Northwind database. And if you don't see that listed, which you probably won't, good news is it's installed on your computer. You just have to open up a template. So up along the top here, you'll see it says More Templates on the far right-hand side. You're going to go ahead and click that More Templates option. And from here, under Search for Online Templates, go ahead and type in Northwind. Helps if you spell it correctly. And you'll see that option pops up. Go ahead and select that option, give it a name. You can put it wherever you'd like, maybe in your documents folder or in your downloads folder, wherever you like to keep your data. And this will just download a copy of this for the Microsoft Corporation and then put it right on your machine. So I'm going to call this one Northwinds. Alrighty, and we're going to go ahead and put it in our documents folder, and we'll click create. Okay. Now, what's nice is you can download this as many times as you'd like. So if you screw it up, don't worry. Just go repeat this exact same set of options again, and you will get a fresh copy of that database. Now, you'll notice once you get started here, it'll say security warning, active content has been disabled. Not a problem here. Go ahead and click that enable content. That's going to pop up. And the Northwind database is a more comprehensive example. It's got reports, it's got queries, it's got forms, checklists, and more, even a login for your employees. And so we're just going to take Andrew's login here. We're going to click login, and we are now logged into this database. Normal databases using MySQL or MS SQL or Oracle, they don't look like this. This is just Microsoft's desktop tool. So don't get too comfortable because, you know, in real databases, it looks very different. Now we're going to click over here to the navigation pane on the left-hand side, and this is going to show us the different aspects of the database that we're working with. Okay, we're just going to click down here on this little arrow. Okay, and from that little arrow, we're just going to go ahead and select, and we're going to say show this by object type. And we're primarily going to be working with the table view. These are the different types of tables. Okay, so we got information for customers, employees, inventory, orders, products, and more. And up along the top here, this is the different ways that you can interact with this database. We're going to click over here to the create. And from the create, we're primarily going to be working with the query design view. Okay, so hopefully yours looks roughly like this. And we're going to come back and look at that here in a little bit. But that's how you can get ready to work with your database. Just using a standard database tool that comes installed with Office for many, many years, Access, and that sample Northwinds database. And from there, hopefully this will spark the content then your ideas and motivate you to, maybe take the knowledge that we're going to learn today in this simple database and expand it to your business's data. But let's go ahead and discuss a little bit more about how databases come together, cardinality, the different verbs that we're going to be using, and ultimately, let's go ahead and come back to this screen and create a couple of sample queries that will pull data out of our Northwinds database. All right, let's go ahead and have our first review question. And then we'll go ahead and continue that discussion. What language do we use to manipulate and work with databases? Okay, and I'll preface this could be a little misleading because technically you can work with all of these languages in the context of data, but there's one language in particular we're going to be working with primarily with databases. Now, is it C#? No, it is not. Is it M? No, it is not. Is it PHP? No, it is not. The correct answer is structured query language. And with structured query language, what we are really working with here is that we are working with the raw underlying data of the actual data itself. And we use SQL to manage that experience. SQL allows us to most directly work with the data. The other languages listed here, like M, well, that's going to be the language of Microsoft Power Query and Excel. Absolutely a data language, but it's still not necessarily working directly with the data itself. C# is a programming language. We use it a lot with databases, but not the data. Likewise with PHP, it's a programming language and doesn't necessarily work directly with the data. The correct answer here, again, is going to be that structured query language. Now, as with all databases, one of the hardest things to get started with is just understanding the taxonomy of the actual data itself, understanding how the data is organized. Now, just like when you go to write a Word document or design your favorite spreadsheet or anything else, I mean, you can do it any number of ways. Certain applications, for example, like Quickbooks or Xero, they're going to already have their schema set up, but it might take some time for you to be able to understand how that schema comes together and then how the data itself is organized. And a big component of getting started with any database project is just understanding where the heck things are and how data gets organized between it. In the context of our series here, we're not going to really kind of go into, let's say, best practices for creating databases. That's definitely a more advanced topic. We're really going to be working with schemas that have already been designed and developed by other people. So we're really going to be limited to whatever that person, that company, that vendor has decided on how to organize their data. And once a schema is designed, you're kind of locked into it. It becomes increasingly more difficult to be able to change that schema the longer and longer that database is in use. So it's really important for the stuff you do create on your own, you get it right the first time. And for the products and services that you choose to use, it would be really helpful for you to understand how that schema comes together, because it's going to make your life easy or difficult. So the schema dictates the tables dictate the columns and rows, and understanding how these things all come together is one of the most important aspects of working with the database from the get-go. I have worked with hundreds of different products and services and databases over the years. The process, the mechanics of pulling data out is always pretty much the same. Where I have to spend a lot of time with a new project or a new client is just understanding their schema of how their data is organized. Now, the good news is this Northwinds database here is a pretty flat database, meaning it's not super complex. There's not a lot of linking tables. There's not a lot of, things that are difficult to understand. And also what's really nice about it is the names of the tables, which are the holders of data, they're representative of the content being stored, So we have a suppliers table. So what does that contain? Well, guess what? It contains vendor information. It contains the suppliers of who is selling to Northwind. It contains a customer table. Well, what's a customer table contain? Well, that contains the company's customers who are buying things from Northwind. So if I wanted to go find who's selling stuff to us, we go to the suppliers table. If I want to find stuff from people who are buying from us, I'm going to go to that customers table. And that something as simple as that is very nice because it makes it very easy to be able to understand how data is organized. Likewise, we have an employee table. The employee table is going to dictate who works for us and all information related to that, like their name, their contact information. Guess what? We're going to go to that employee table to find it. Now we have a product table. All the products are going to be there. You wouldn't see, for example, orders. Why? Because you have a order table. But that product table is where we're going to find the characteristics of the products being sold. So color or width and height and weight, category, things of this nature, that's where we would go looking for it. Now, we also have order and guess what? Order details. Now, this is a really good example where sometimes within databases, you will have a macro and a micro table. And sometimes you can have several micro tables depending on what you're working with. In the context of Northwinds here, the order table is going to contain the high-level stuff related to an order, and it's going to have linking tables that will provide additional support information. So, for example, in the order table, you probably wouldn't see something like the name of the customer or the address of the customer, but rather a ID of that customer that would then be used to link to the customer table to pull that information up. Okay. Likewise, in the order table, you'd probably see things like tax, or you might see the shipping date, the invoice number, so on and so forth. But you know what you won't see? You won't see the line items of that invoice. Why? Well, line items could be quite varied, and we sometimes don't want to have all that detail cluttering up our big tables. So we'll create a detail table or a micro table that'll contain that additional information. And sure enough, with Northwinds, we have that. The orders table contains the big stuff that we need to know. The order details table is going to contain the line item detail for the order, where each line item would represent a single row, and that row would be one entry on the overall invoice. Okay, and so one order might have several order detail line items, but an order details table row would only have a single order that it relies to, because an order can contain many line items, but a line item will only relate back to one order. And that's a pretty common thing that you'll see with database design. If you're going to have to understand how much data is being stored, might dictate that you need to have several tables to store that information. Now, if that sounds confusing, trust me, it was, at least for me initially when I was getting started here. I remember thinking, why not just put it all on one table? Well, you start to run into some real interesting limitations when you do all of that. And it's actually simpler and easier in the long run just to have separate tables to store this information. And folks, I'm going to tell you right now, that is going to be a defining characteristic. The second you can understand that, the need to break information into several different tables, you're going to pick this stuff up much quicker. That's a real central principle behind this, is that we don't store everything all in one place. We store them in single purpose tables that just store the information related to that table. Now, let's visualize our Northwinds database here, and let's take a visual look of how this all comes together. And so this is a schema document. The schema document will dictate how the database comes together and how different things are related to each other. Okay, and let's zoom in on a few things here to hopefully make this a little bit easier to understand. And let's just go ahead and first take a look at our customer and orders. Now, a couple things you're probably going to notice is that first off, you've got different types of icons representing different things. You've got dotted lines, you've got hard lines that ultimately do different components. And what the heck do all these different things mean? And we're gonna stipulate and discuss some of these specifics here in an example. But the big picture that I want you to kind of think about is this is the diagram that shows all the different types of data and how they all fit together, okay? When we're designing databases for business, we are often thinking about what data is going to be stored, how is it going to be used, where is it going to go, and we need to find a home for every little bit. So like if you want to have information, for example, on the customer's shipping information or their postal code, well, when we design the database, we have to find a place for that to go to, okay? So that's exactly what you're seeing here. When we think about databases, we think about the container, and then we think about the different things inside of that container to hold different bits of information. And we typically want to store these things in their smallest possible unit, which is what you're seeing here. So if I needed to store, for example, 2 phone numbers, as you can see over here on the lower left-hand side for customers, we could have phone and phone 1, or it could be phone and mobile phone or something like that. But if we needed to store more data rather than multi-purpose a column and just tell people to comma separate it, we would create another column. And each of these represent the table, and then the words represent each column of that table. Okay. Now, the next thing you're going to notice is that for a lot of these components, they have either A, B, C, or 1, 2, 3 next to it. Well, unlike a spreadsheet where a worksheet can contain anything you want in any cell, in databases, we're more rigid than that. A database column is going to be set to a specific data type, and it will only ever hold that data type. So for example, something like, that is just text data will only hold text information. Something that has number data is only ever going to hold number information, would not be able to hold, for example, letters. Now, sometimes we can create something that might sometimes have a number, sometimes have letters in it. We typically call that a varchar. Well, that can contain both letters and numbers, which is example of that would be an address, which might and very well probably will have both letters and numbers into it. So when you're thinking about your tables, you want to think about the type of information that's being held there and match the format to the data that it's going to contain. And if it only ever is going to contain a number, you set that column to a number. And if it's going to contain text or time or date, you do something equivalent to it. Okay, so that's what that little ABC represents. Okay. Now, the next bit, you might notice that, for example, there are dotted lines and that there are straight lines. Okay. Well, straight line represents primary keys, and then the dotted line represents foreign or secondary keys. Looking over here on our order table, you can see that we have to our order detail table, order ID and product ID. Well, that represents that relationship, and it is directly tied. Those two tables are directly tied to each other. For our customer ID over here, we can see that same thing. We've got some specific tying it back, where over here on the order table, we can see that we have customer ID, and that customer ID is tying back to the customer table. Now, there's some specifics around this between primary keys and foreign keys, as well as one-to-one relationships, one-to-many, and vice versa, and many-to-many relationships. We'll talk about that here in a minute. But as you start to get in depth with working with databases, understanding how they come together and understanding the relationship between things is going to be very, very helpful for you. Okay. Now, generally, when we're dealing with schemas here, ideally, almost everything should touch something else at least one time. 99% of the time when you're working with databases, everything has to be touching something everywhere else. But if it isn't, that can cause issues, but it's not always 100% of an issue. And the more you get into the knowledge of databases, the more you'll be able to understand this a little bit more. But for those of you who are just getting started off now, just always make sure your tables are touching something else. And this will be very true when you're working with something like Power BI. I'll give you a quick analogy in terms of how you can think of maybe all these things connected. If you've never been to St. Paul, Minnesota or Minneapolis, all the buildings in downtown, they have these sky bridges. And it doesn't matter where you are in downtown, you can get to any other building without having to go outside if there's a sky bridge connected to it. So I could be down here on my customer demographics, but I could get my way all the way up to my suppliers if there's a sky bridge. And that would be the same of these like little lines connecting things. You want to have your keys that can ultimately go back to the different tables. And then from those different tables, you can get to wherever you want inside of the database. Now, if something doesn't have a sky bridge, doesn't have a little table, you'll notice over here on the United States listing of states over here, well, that makes it isolated and there's no way to be able to easily get that data. And that's generally something you would want to, generally it's going to be something you're going to want to avoid. Okay. At least until you know a little bit more, and then you'll realize there's sometimes you don't relate tables, but most of the time you will. Now the tables, just as a reminder, they all look the same. I mean, database tables just contain data. They are a collection of rows and columns. Rows and columns are a collection of cells, and that's exactly what you see here. We have our customer table on the left. We have our order table on the right. We don't need to, in our order table, have the first name, the last name, or the zip code of the customer, because why? We have this customer ID. Okay, and if we know the customer ID, let's say 1145, well, knowing that, we can go and look up the customer to the customer table, and from 1145, we can know exactly who that is. And so from 1145, we can see that it is Marge Penner. We can go and easily see and pull her name, her address, and zip code there. Let's say we had customer ID 10046. Okay, that could be Janelle. Well, if we know that it's 10046, we can then go and look up to our customer table and see 11046 is Janelle and see that she lives in Arizona and pull that information directly into our report. There's no need to duplicate or repeat yourself on a table by table basis. Now, when you're starting to write your database query, there are a couple things I would encourage you to think of, okay? And I want you to think about these now as you start to write your first queries, and I want you to remember them forever, because this is usually what is going through my mind when I'm starting to think about how the heck am I going to write this and be able to present this information in the report, okay? First off, if you haven't at this point in time, understanding that database schema is going to be imperative. You know, you're going to have to understand how your data comes together. So first and foremost, familiarize yourself and understand where I can go find customer information, order information, product information, or whatever else we happen to be working with. Okay. And from there, I want you to think about what tables contain the data that I'm looking for. So if I want to write a report that's going to pull orders and customers and products, knowing where orders, customers, and products information live, that's going to be super important. Okay, so first think about objectively where your data is located. In the same way that if you needed to go look for a hammer in your house, what room do I go look in to go find that? Well, hopefully it's the garage and the workshop. What is the column structure of those tables? Okay, so for customers, do I have one customer table or is there a customer details table? Is there an order table? Is there an order items table? What is the structure of those tables and what data is contained inside of those columns? And what ultimately do I need to connect to get that information? Okay. What key represents that specific record? Is it order number? Is it customer ID? So on and so forth. But think of how you're going to walk the sky bridge between the different databases here to find and basically tie it all together, you know, and it's going to be through relating through these different keys. And how do I relate whatever table I'm working with to the primary key of whatever table I'm looking to use? So for example, understanding order ID on the order details table will relate back to the order table, order ID column. From the order table, knowing that the customer ID column or the ship to ID column or the bill to ID column relates back to the customer table. Okay, so these are the questions I usually think about, and I always try to identify, for example, what is the most raw, most important data that I'm working with at any given time. Alrighty, so let's go ahead at this point and maybe just write a very, very simple example of a query, and then we will come back and we'll start to look at some of the other major ways that this information comes together. And what we're going to do now is we're going to write our very, very first select statement. And a select statement will grab data from a database and then return it back to us. Okay, so let's go take a look. Now, back in our Access database here, and again, we went to the Create tab, Query Design, okay, which is this view down here. And we're actually going to just solely write some SQL here because I think it's important for you to know how it comes together. And in the lower right-hand corner, there's a little option down here that says SQL, okay? Just go ahead and click that little SQL button. And that little SQL button, again, is like right over here. You know, just click that little guy and that's going to pop up here. Okay, we're going to write our first one. And let's just say, for example, we just want to see all of our customers. We're going to type in select star, okay, from, and then we're going to say customers. And we will click run. Now, what that does is it goes to our customers table and it gets all of our customers and it gets all the columns that represent our customers here. And so we can see here we've got about 30 customers. We're storing the name of the company, the first name, the last name, the owner, the fax number. I guess if 1996 calls, you need to fax them something, you could do that, and where they are located. Okay, and we're doing that through just this, what we call a basic select statement or a query. Okay. Now, this query is pretty much as simple as you could possibly get. You'll see it says the word select. That tells the database we are querying data. It has an asterisk, which means get me everything. And then there's the word from and then the table of customers. So if we were to read this kind of literally, it would say, hey, go get me everything from the customer table. Now, from this basic query, this is where we can start to scope out a more complex or more limited or a more filtered view of whatever data that we're looking for. But this is the basis of that report. Get everything from customers. Now, knowing how to write the order of these words and using the correct verbs and the correct nouns is as important in SQL as it is in the English language. If you don't say the right thing, you won't get the right response. But this is how we do it. It's as simple as this. And I will tell you, a lot of people, when they're getting started working with databases, they want a GUI tool. They want a graphic user interface. If we just switch the view here, we kind of go back to Access's visual tool here. This is what this looks like. Let's do the same report using the graphic tool. But what I want to encourage you to do is I want you to struggle. And I want you to write and learn how to write this using SQL and not using a graphic tool like this. This is a great way to get started, okay? And it's a great way to be able to kind of understand visually how this comes together. But tools like this are a massive, massive, massive crutch. And if you don't learn how to kind of turn the page and learn how to write the basic SQL, you're never going to be able to use this effectively. Okay, so use this to get started, but as fast as you possibly can, graduate from using a tool like the graphic tool like this and learn to write the code yourself. It will, after you learn it, you'll be like, oh my God, why would I ever want to use a tool like this to begin with? And the answer is never. The answer is never. Once you know how to write it, you write it. Okay. But that is your basic select statement. And that is what that looks like. Now let's go take a look at that select statement and let's understand maybe the words a little bit more about what they mean. So your basic select statement is a query to the database, and it's a selection of words put into a specific order that tells the database to go find specific data and then to pull that data back and display it to you in your specific order and the view that you are looking for. It's not hard. It's not difficult. Once you kind of understand some of the major words, then you'll have a pretty good way of how this all comes together. Okay, so every query to a database starts with the word select. Always select, 100% of the time. So select what? Well, we tell it either get everything using the asterisk, or we say the specific columns that we are looking to get. Okay, and there's a specific order that you should probably list these things in. But for the most part, it doesn't really matter how you get the columns and what order you put the columns in your report. It's up to you, but just know it always starts as select. Now we can alias things. So maybe, for example, inside of our database, it will say, order under, and then like an underscore, and it'll say ID, and you just want it to say order number. Well, you can alias things by giving and telling it to call it a different column. And we can use that as verb to tell it to do that. Okay. Now we have the from. The from specifies where to get the data, and we can often have several different places that we can get the data, but from, for that specific table, that should be the root, the most primary data that we're looking to get. For example, if I was looking to just get data about orders and I wanted information about the customer, I would say go get order data, and then I would choose to join that data from other places. But in the from, it would be the most primary place of where that data is located. More on that here in a little bit. Now, if we need to get data from additional places, like from the order table and then bring in customer data and product data, well, we use a join. We'll talk about that here next. But a join basically says, hey, whatever table I'm working with doesn't have all the information. It needs to come from other places too. Well, join and grab customers, join and grab products, so on and so forth. So thus far, to summarize, go get whatever data we're looking for, and here is where to go find it. Now, if we want to limit the scope of what we're looking for, like filtering the data down, we can use a where clause. And this specifies what rows to retrieve. And this could be, for example, where customers are in the state of California. It could be where orders are over $500. We can specify by filtering down to get exactly the cut of the information that we're looking to receive. And it's as surgical as a scalpel in terms of what records you can choose to get back once you know how to write the SQL. We can aggregate information. Okay, in a couple of different ways. We can group things together to make it easier for whatever we're looking to do. So if we wanted to sum, if we want to count, if we want to find the min, the max, so on and so forth, using the group by allows us to perform some sort of aggregation of the data and return back not the original data, but an aggregate version of this. That can be really helpful, for example, if we're looking to write a report and sum all of our sales in a specific state. Well, if we use the group by and sum the data by state, well, now we don't end up with, 7 million rows. We end up with, roughly 50 rows of data. Maybe the provinces in Canada or the territories or whatever might add some additional, but we would see a single number representing California or Nebraska or wherever else we happen to be working with. Having is something that we can also do. We'll save the group by and the having for a more advanced version of this class. Okay, so stay tuned on there. We can order the data in terms of the rows that we get back. To go back to our example of sales by state, well, maybe we want to put it in alpha order. So we can say order by state name in alpha order. So we would see Alaska and Alabama and Arkansas before we would see, for example, California, and something like Washington or Wyoming would be at the end, assuming we were putting it into ascending order. If we put it into descending order, it would go the other direction. Okay. Or if we wanted to see sales by state, but by revenue, okay, well, we could tell it to order by the sum of the revenue column, and whatever state had the largest sales could be listed first or last, and then vice versa. We can also tell it to order by something and then by something else. So if we were, for example, doing something like name, we could say, hey, order it first by last name and then order it by first name. So we can group things that way. If you're familiar how to group in Excel, it's the exact same thing. Now, the hardest thing I think people come into knowing with respect to working with databases is the joins. It's the relationships of pulling the data together. We have lots of different ways that we can group this information together, but maybe this little diagram can be helpful in terms of understanding how this information comes together. So let's say we've got customers and orders. Well, first off, we want to determine what is the most primary information that we're working with. Is it customers? Like, I just want a list of my customers, and if they have an order, great. Or do I want to just see all of my orders and then see the customer information that goes along with it? Well, that will determine if we use a join, a left join, or a right join on the SQL statement. So let's say, for example, we use a right join. Well, if we were to go and pull all of our orders and join the customer table to it, an order would not appear unless that customer had placed an order, and vice versa. An order would not appear unless it was associated to a customer. So when we join data together, we only pull stuff together where both the ID of that particular record exists in both tables. Sometimes, for example, though, we want to pull just, for example, a listing of all of our customers. And then if they have an order, great. But if they don't have an order, I still want to see all of my customers listed. That's where a left join can be really useful. This allows us to show all the records of a specific table. And if a record happens to exist in that other table, it will pull through too. But if not, oh well, it won't be displayed. And this kind of comes back to this idea of cardinality. Okay, so with cardinality, what we're thinking about is how data inside of our database matches up. And really, it's going to be one of four options: a one-to-one, a one-to-many, a many-to-one, as well as a many-to-many. And in my experience, 99% of the time, it's going to be one-to-one or one-to-many. Very rarely will it be many-to-many. And in fact, I'm not going to say you should never have many-to-many, but usually that's more reflective of poor database design than anything else. In my experience, almost everything just uses one-to-one or one-to-many. But understanding how these come together is really important, because ultimately, this will have a huge impact on the query and whether or not you get the right response for your question. Let's take an example. Let's take a look at how cardinality works for databases. So here are our main types of relationships: one-to-one, one-to-many, many-to-one, and many-to-many. So an example of one-to-one is pretty simple. It's stuff that we see all the time. An employee, for example, only ever typically works in one department. So we have one employee would equal one department. Okay. Now we have one-to-many. For example, a publisher can publish many books, but a book will only ever have one publisher. Okay, so your publisher, like Random House, publishes thousands of books, but typically that book will only have one publisher. Now, granted, you can have differences in markets. You might have a European publisher, an Asian publisher, or hardback versus paperback, but for the most part, it is one to many. Now, we could also go many to one. These are virtually the same. So in this particular instance, a book can have many sections, but a section will only ever contain or be in one book. It's pretty much the same relationship. Now, we could also do many to many. And again, it's not always bad design, but it usually is reflective of that, where a course, for example, can have lots of students in it, and a student can also take many different classes, many different courses. So understanding kind of how the table design comes together can be really important, because it's going to have a huge impact on how you scope your query. In fact, if you look at the database design, we even have symbols to represent this. If you look at two tables, you'll see they'll sometimes be a straight line. Well, that represents one to many. And then we have this thing called a crow's foot, which is, three little things popping out. And that would represent, depending on what side it's on, either a one to many and in what direction that is. And if it's got crow's feet on both sides, well, that represents that many to many. So that is kind of, in a nutshell, probably one of the most complex topics with respects to databases, and understanding how those different topics are related to each other will help you as you start to, in your head, visualize how that table is going to come together. Okay. And knowing how the database is organized, where data is located, how that data is organized, where the keys are, well, that's going to start to be really, really, really important when you start to pull data out of there. Now, let's go ahead and write a couple of different examples of table queries that might be helpful for what we're looking to do. Okay, so we've got a couple of different examples of some general queries that I want to write. Okay, let's get all of our customers. Let's get all of our orders. Let's get all of our orders with order detail. Let's get some different examples where we bring in product, customers, so on and so forth. And let's even take a look at what it might look like to narrow down our order with specific characteristics, maybe a specific state or something else that represents that order. Alrighty, let's come back over here to Access and let's go ahead and write our next query. So we already got all of our customers. Let's just go ahead and take a look at what it would look like to get all of our orders. So we're going to type the words select, and we're going to do our star saying get every column in this query. And we're going to go ahead and say from orders, and we'll go ahead and click up here to the upper left-hand corner, and we're going to go ahead and select run. In doing so, there you go. That is all of our orders. Let's come back over here and go to our SQL view, and let's take a look at what it might look like to get only selective things and selective columns from our table. So one of the things I often do is what we call aliasing. And so in your from as well as in your joins, instead of having, becomes really helpful, especially as you start to have more columns associated. One of the nice things you can say here is that you can just put the word or letter that represents that, and then use that word or letter in the actual query anytime you intend to use that same table going forward. So instead of saying, orders first name, orders last name, I can say orders and then put an O in here. And then what I can do going forward is I can just type in what I'm looking for. And I can use O dot whatever to get the specific column that I would like. So let's say for our orders here, let's say we wanted to go get our customer. And let's say we want to get our order ID. Actually, let's say we'll get our order ID. Okay, so we're going to go ahead and do this. Now, one thing with SQL, as you go to the next columns when you're writing this, you always have a comma. And that comma just basically says get the next row or the next column. All right, and I can never remember with Access. Sometimes you need to put these things in double quotes. Hopefully that works there. Let's try maybe this. If I was a smarter man, I would have put this together. Oh, no. Okay, hold on. And this is very reflective of Access. In SQL, normal SQL, that would just work normally. Okay, let's see. Why don't you like this? Okay, well, this is a good example of where normal SQL can be very different than Access. Access has its own brand of it, which can sometimes be confusing. But the point of what I wanted to show you here was that we can limit our query to only include certain columns. You don't have to include everything. Okay, and looking at the SQL statement for this, and I was darn close. Okay, O.order ID and O.customer ID. This is the language that we would use to only get back certain columns of what we would like it to be. Okay, so I would typically do something like this. Let's try that again. There you go. Okay, now if we wanted to throw a third column in, we would do O dot, and then it looks like the syntax of this would be open bracket. And let's say we wanted to get the order date. All right, we'll do that. And we're going to ensure that we have a comma after our second row there. Your last row of this, you don't have to include a comma. So it's only if you have additional ones. Okay, so if we run this, now we have those third columns listed. Okay. So that is how we can pull data out. Now, let's say we wanted to go and from our order table, we also want to get information about our customers. Well, that's where we would use that join. Okay. And so we'd say join, and we're going to use the name of that column or that name of that table. So we're going to say customers, and we're going to say as C, and then we're going to tell it how to join. Okay. And so for our table here, we're going to say join our customers on O dot customer equals, and then we're going to use the name of the order. We're going to use the name of the customer column there. Okay, and so we're going to say C, and then we're going to go open bracket here, and we're going to go ahead and say, what would that be? That would be customer. There we go. Oh, actually, no, it would be C.company. So sometimes that can be a little confusing. And it's, all right, let's try that like that, and let's run it. Why don't you like that? Oh, God. Sometimes running SQL inside of just this specific tool can be really frustrating. But it's a tool everybody at least has or is familiar with. Let's just bring this back into this normal view. All right. So we'll bring over here, and we're going to drag our customers in here. And actually, understanding this isn't the worst thing in the world. Where we would ultimately end up tying these two things together is that we would tie them. We would tie them together, probably using the invoice table, I'm guessing. Let's see. Yeah, invoices. There we go. Okay, and then we would probably have to pull in order number. Let's see, and then we've got our invoice, probably a transaction table of some sort. All right. Employee customer ID. Oh, God, I'm an idiot. Right, there we go. Customer ID, and that would tie back to that. Okay, so from here, let's go ahead and get rid of this table because we actually don't need it. We just need these two. Okay, always good to know. Okay, just like this. And let's grab our first name and our email. So we're just clicking additional columns in here. We'll click run, and there you go. That's how you would ultimately get this data in. But as I mentioned, SQL, or not SQL, but Access has its own funky language of how these things come together. Let's just take a look at how this would look. And I shouldn't say it's maybe about 30% different than what we would see with normal SQL, just enough to be very confusing for somebody who knows what they're doing here. And this is ultimately what we're going to see here. So, and how it will come together. So we've got our select up top. Okay, we've got our order ID, our customer ID, our order date. We've got our customer tables, the name of the customer, last name, first name, and email. And then we've got our join statement. So the most primary thing we're working with here is our order table. And then we're adding some customer information. So we're telling it to go to the customer table. And then where customer ID matches between the two of these things, go ahead and pair them up. And when we do so, we get a very nice report here on a per order basis where we can see who the heck actually made these different orders. Now, if we wanted to, we could also come back over here and we could put these into a specific sort sequence. So if we wanted to sort them based off of the last name of the person purchasing or the order, we could do that as well. And that would be our order by. And let's see if I've got some luck today. Let's put them into last name order. Hopefully this works. ASC for ascending space. Let's see if that works. There you go. I got a free one there, folks. Okay, and so we can see here it's putting those into that last name order in the correct order for us. So that is a little bit about how we could organize this information. And we can also narrow down focus based off of specific characteristics as well. We call that a where clause. So as an example, we could only show orders that are of a specific dollar amount. So if we wanted to, we could even pull in, if we've got a column for that, for like the order amount there, where an order is only above or below or equal to specific thresholds, or only contains certain products. We're going to be looking at those specific examples of how to do those order filters in the next podcast, where we start to narrow down and just get the stuff that we're supposed to get using the wheres. So lots of options with respect to SQL. You can really kind of, I would say, be surgical with the data that you're going to get back because the information is so specific to what you ultimately can get based off of the language that you write. So we're just about out of time here. Let's go ahead and finish. We've got 2 review questions, and then we're going to go ahead and wrap up for the day. All right, our first review question, or second review question, what type of join only returns the records where everything matches? Okay, so is it going to be our left join? No, it is not. Left join will get only the stuff if it happens to exist. So it'll only return the records if they happen to be there, which is really useful because if I wanted to get all of my customers, regardless if they had an order or not, I'd use that left join. Would it be a full outer join? Nope. Wouldn't use that either. Would it be a non-duplicate join? That doesn't exist. If I only want to get where everything matches together, that would be that right join or normal join. Okay. For a normal join, if we were looking on customers and orders, it's only going to get it where everything actually ties out. There's an order and a customer. And so if you had a customer without an order and you were using a right join to the customer table from the order table, it wouldn't show you anything. It wouldn't show you that order, or it wouldn't show you the customer who had never placed an order yet. So it might be limiting, because it's answering a different question. If you're looking to get the answer to the question of how do I just see all of my customers who placed an order, well, then that would be a good option. But if I just want to see all my customers, maybe that person hasn't created an order yet, well, we would use a left join, so that way we would at least see that customer pop up. All right. So again, you get the options here. You can be surgical with respect to how you pull your data out. Okay. Third review question. What part of the select statement limits the scope of the query to only specific types of records? Okay. Well, again, this can also be interpreted a couple of different ways, and technically pretty much all of these can limit the scope in one way or the other. But the from is going to tell us where the data is coming from. The group by would aggregate that data together. The order by is going to put it into the most specific order. The most correct answer here would be that where clause. The where clause allows us to be very surgical with the data that we're pulling out. And in fact, with that where clause, we can do some really kind of cool stuff with it. We can search for specific conditions that are only matching whatever we're looking for. So if we wanted to match an order to specific states, or if it's over a certain dollar value, we could do that. And the search condition allows us to also be able to combine different types of logic. So we can say, show me all orders from California and over $500, or show me all orders from California or Washington, so on and so forth. For numeric operators, we can use inequalities. So we can say greater than, less than equal to, greater than equal to, not equal to, equal to. We can be very, very specific about the data that we're looking to get back. We can also, if we don't have an exact answer of what we're looking for, we can use fuzzy logic, and we can use wildcards. We can use the percent symbol as well as the underscore to match part of the words that we're looking for. So if we wanted to match the first part of a record, maybe we're, for example, matching the first part of a GL code or something else. Well, we can use that wildcard operator to match the beginning or end of something. Lots and lots and lots and lots and lots of options here. Alrighty, well, that does bring us to the end of our class here. Lots more coming in this specific webinar. I'm honestly kind of blown away once I feel like I started talking here. There's so much knowledge I want to provide. So I think we're going to keep going with this series because I think this is a topic that is going to be very helpful for many of you getting started with databases. But today, we talked about the major components of a database query, the characteristics of how tables are designed, how multiple database objects come together. We also talked about how to write a select statement. In the next episode, I think we're going to need to spend some more time on aggregation. I think we're going to need to spend some more time on the where and filtering and ordering. So lots more here to come. And we're going to go through some more, let's call them beginner database techniques that are a little bit more complicated, but I think are going to be super important for you to know how to use. And I'm also going to introduce some additional tools on how to work with databases to make it more easy and effective. I got some tricks up my sleeve. It's going to take me a little time to pull these things together, but stay tuned. I think there's lots more good information to come. And if you are a financial professional, how about you get some credits for today's class? Head on over to cpetoday.com. Our course code today is DBB2. Again, DBB2, Delta Bravo Bravo 2. Take a short 5-question quiz, earn a credit for today's class, and you'll be well on your way to maintaining your license. And if you are a new watcher or listener to the CPE Today podcast, thank you, thank you, thank you. You are my hero. Welcome. So happy to have you. How about you get a free credit on us? Use coupon code ONEFREEPODCAST at checkout, and you can get a credit for watching or listening to today of this class or any other course of your choosing. If you like the channel and you want to support us, one of the best ways you can do that is to help us spread the word. You can find us on social media just about everywhere. You can find us at CPE Today. And if you like our content, please consider subscribing. We're a young channel. We're a growing channel. We're trying to get more folks involved. And subscribing wherever you happen to receive content, YouTube, Facebook, wherever else, was a great way to support us. We'd also love for you to leave a review or a comment. That really helps us know what we're focusing on and what people are actually interested in learning about. Thank you so much for your time and attention, folks. It is always my pleasure being with you here today. I'll see you back in the office the next time around. Take care.